Hello students, hello everyone. In this video, I am going to discuss one topic, memory representation of 2D array, two-dimensional array. And this video will be helpful for the class 12 students who opted computer science in class 12 in ICC board. This video will be helpful for them. Okay. So there will be a question related to this. There will be a numerical question related to this topic in class 12th board examination. That particular numerical question I'm going to discuss in this video. Okay. And please watch this video carefully and you will secure 2 marks. There will be a numerical related to this topic in the board examination. Okay. So it's completely formula based question. There will be a formula. You have to put the values will be given in the question. You have to put the values and you have to find the some values in that formula. Totally formula based question. So I will explain from the basic. So try to understand it. So let's start without wasting your and my time. Here we go. So the topic is memory representation of 2D array. Okay. Here, two methods are here for memory implementation in 2D array. Let me tell you, before that, I have uploaded one video in which I have discussed about 2D array. The basic concepts of 2D array I have already discussed. How to declare a 2D array, how to take input, how to display the elements of array 2D array, and how to initialize the elements of 2D array. These things I have already discussed in a video which I have already uploaded in this on my channel. So please watch that video to know the basic concepts. Okay. Now I'm going to discuss what is row measure and column measure implementation in 2D array. So first I'm going to tell you when I have taught basic concepts of 2D array, there I have told you how to declare an array, how to declare a 2D array. I told you that type of array, the name of the array as you decide the name of any variable, then square brackets, 2 square brackets in case of 2D array, then new, and again the type of the array, and number of rows and number of columns. In case of 2D array, we have 2 dimensions, rows and columns, number of rows and number of columns. So this first dimension represents number of rows and this indicates number of columns. These everything I've already discussed in my previous video. You can see that to know the basic things. Okay. So what happens in that video? I have told you what happens when we declare a 2D array in this manner. What happens? New operator allocates memory for 3 rows and 4 columns. Okay, so memory will be allocated like this: 3 rows, 3 rows, and 4 columns. Okay, here 0, 1, 2, these are row index, and 0, 1, 2, and 3, these are column index. Okay, so when we declare a 2D array in this manner, what happens? New operator allocates memory for here. The new operator will allocate memory for 3 rows and 4 columns. Okay, in this manner. Okay, consider I have taken after declaring we are taking input. Consider it we are taking input and we are taking input the values. Consider we are taking 2, 5, 3, 8, 7, 6, 3, 31, any value, 50, 22, 27, any values we are taking. Okay. These value consider after declaring 2D array, we have taken these values we have taken input these elements in the 2D array. Okay. Consider it. Just consider it now. Listen. What if, but actually memory is not allocated. This is the concept which I'm going to tell through this video. Actually, the memory is not allocated in this tabular form. This we are writing, this we used to write for our convenience, that we we should know the number of each row separately. Okay, this we write for our convenience. Okay, that how many rows and how many columns are there in each row, how many elements are there, what are the elements in each row. For this convenience, we used to write this 2D array memory representation in this manner. But actually, the memory is not allocated in this tabular form. This we write for our convenience. Okay. So what happens actually? The memory is allocated. I'm repeating. Memory is not allocated in this tabular form. Actually, the memory is allocated in linear form. Okay. And there are two methods of this memory allocation: row measure or column measure. That is row wise or column wise. So if the memory is allocated row wise, okay, then what happens? The elements of first row, then the elements of second row, then the elements of third row, and so on like this. If the memory will be allocated row wise, in that is called row measure implementation. So what will happen? The memory will not be allocated in this tabular form. The memory will be allocated in linear form, and there are two methods: row wise and column wise. Okay, if it is allocated row wise, that is called row measure implementation. So what happens in row measure implementation, that I'm telling you? The elements of first row 0, 1, 2. What are that? Here 2, 5, 3, 8. Row wise. Okay. The elements of second row 7, 6, 31, 50. Then the elements of third row. What are that? 22, 27, 29, and 10. This is row measure implementation. The elements of first row, the elements of second row, the elements of third row. Got it? Okay, and if the implementation is column wise, that is called column measure implementation. If the implementation is column wise, in that case, same thing, the elements will be allocated, the memory will be located in linear form, column wise. Means this is what? This is row wise. That is called row wise implementation. If column wise, if the same thing will be column wise, then what will happen? See, elements of first column. The elements of first column, that are what? 2, 7, 22. 2, 7, 22. 0, 1, 2 index. Then elements of second column. That is 5, 6, 27. You can see in this array. From here I am taking the values. Now elements of third column. That is what? 3, 31, and 29. Then the elements of fourth column. 8, 50, and 10. So this is called column measure implementation. The elements will be allocated in linear form, column wise. The elements of first column, then elements of second column, then elements of third column, and so on. So this is the concept, basic concept. Actually, memory is not allocated in tabular form. It is allocated in linear form in case of 2D array. And there are two methods for that: row wise and column wise. And if it is row wise, the elements of first row, second row, column, third row, and so on. If it is column wise, the elements of first column, second column, and third column. I have explained thoroughly too many times. I hope the things are clear. Okay. So this is the basic concept of row measure and implementation and column measure implementation. Okay. Now I'm going to tell you the question which will come in your examination. Okay. As I told, it's a totally formula-based question. Totally what? Formula-based question. Okay. So I'm going to write the formula for this. For the row measure implementation, then I will tell you the column measure implementation. And then I will discuss the question related to that, based on that formula. Okay. So here the formula. So this is the formula for row measure implementation. Here we have to find the address of ijth element. Such question you'll have in the examination. Okay. And in this formula, this B is what? Just listen carefully, everything will be clear. Just keep patience, I will make everything clear. It's sure. So listen carefully. This the address of ijth element. Here the B is what? Base address. W is width of each element. LR first row number. LC first column number. Okay, and here n is the number of columns. See, this is the formula of row measure implementation. And in case of row measure implementation, we count the number of columns. We require number of columns. It is what? Number of columns. Okay, and the formula for number of column is UC minus LC plus 1. UC minus LC plus 1 is the formula for number of columns. Okay, so that everything I will discuss. I will make it clear with the question. Which type of question will come in your examination. Through that, I will make everything clear. Okay, so this is the formula. You have to learn this formula. Okay, and this formula is for row measure implementation. Got it? And if you're going to write the formula for the column measure implementation, only slight difference in this formula. Okay, let me tell you what is that slight difference. Same thing I'm going to write for the column measure. I'm just going to copy this. Column measure. Yeah. Okay. Here now I'm going to write the formula for the column measure. Column measure implementation. Okay. This will be the second one. Okay, column measure implementation. The formula is simple. Slight difference is there. I'm going to copy this formula. See. Okay. In this formula, in case of row measure implementation, we require number of columns. In case of column measure implementation, we require number of rows. Okay, in row we require column, in column we require number of rows. So here this n is for what? Number of rows. Instead of this, we will write r. Instead of n, we will write r. And what is r? R is number of rows and will be written here. Only this is the difference. In case of row measure implementation, we are writing number of columns here, that is n. In case of column measure implementation, we are writing r, that is number of rows here. Okay, and the formula rest will be same. Rest things are same. Everything is same. Only the difference is what? Instead of number of columns, here we are using number of rows and just using the symbol r here at this place. Only this is the difference. Okay. Now, second thing. And the rest are same. Only the difference is what? Instead of n, here we are using r. And what is this r? This r is number of rows. That is equal to, here you can see UC plus LC, UC minus LC plus 1. C for column. Here R is for rows. So UR minus LR plus 1. What is UR, LR? Everything will be clear. I will make the things clear. Just keep on watching this video. Don't be confused. What is LR? What is LC? The things will be clear. Here, just understand this time C for column. And this is R for row. UR minus LR plus 1. Okay, so only slight difference is there. So learn only one formula. Learn the formula of row measure implementation. The formula of column measure implementation will be in mind automatically. Please remember the difference. Okay, so I'm going to attempt one question of row measure and one question of column measure to make the things clear which type of question you'll have in the board examination. Okay. So here we go with the first question. See, so many questions I've already copied. So here with here we have the first question. Now listen. See, in this form we'll have the question in compulsory section part 1. You'll have this question, and it is of 2 marks. Okay, so assure this marks by watching this video. Okay. See, a matrix ARR minus 4, 6, 3, 8 is stored in the memory with each element requiring 4 bytes of storage. If the base address is 1430, then find the address of ARR36 when the matrix is stored row measure wise. This is the question. Okay. Now here, this is what LR, this is UR, this is LC, and this is UC. What is the meaning of LR, UR? I'm going to clear it now. Here, R for row, and this is the lower bound of row, L for lower bound, R for row. This is the upper bound of row. Lower bound and upper bound of row. And this is the lower bound LC, C for column, L for lower bound. This is the lower bound of column, and this is the upper bound of column. Okay, LR, UR, LC, UC. Please remember the sequence. This is the lower bound and upper bound of row, and this is the lower bound and upper bound of the columns. Okay. Okay. So please remember the sequence LR, UR, LC, UC. Lower bound, upper bound of row, lower bound, upper bound of column. So now I'm going to through the formula. First, I will write the formula of row measure, and then I will tell you the values one by one. So this formula of row measure I'm copying from here instead of typing again. I don't want to waste your and my time. So let's see. Okay, this is the formula. So I'm going to put the value for each element in this formula. So as per the question, see, B, the value of B is here for base address. So try to find out if the base address is 1430. So the value of B will be what? 1430, the base address. Okay. The value of W is what? Width of each element of that 2D array. So here it is written memory with each element requiring 4 bytes of storage. Means the value of W will be 4. Please try to learn how am I getting these values. Okay. Then N. N is what? Number of columns. So for number of columns, we have the formula UC minus LC plus 1. This I have taught in the formula, I can see. This is UC, this is LC. So 8 minus 3 plus 1 will be 6. This is the value of N. Then LC, now LR. Just take it from here, LR equal to 4 and LC equal to 3. First row number, first column number. LR, LC are what? 4 and 3. First row number, this is first column number. Now we have all the values, and I, here it is said, see, here it is said, find the address of ARR36. I, jth element, 3, 6th element. So I is what? 3, J is what? 6. Here we have to find the address of ARR36, means I is 3, and J is what? 6. Okay. Now we'll put these things in the formula. We'll put all these things in the formula, and we'll try to get the value of the address of ARR36. So here we'll write the formula address of 3, 6th element equal to the value of B is what? 1430 plus the value of W is what? 4 square bracket, and the value of N we have 6 in bracket. I, the value of I is 3 minus LR. What is the value of LR? 4. Is it 4 or minus 4? Let me check. It's minus 4. Sorry. The value of LR is minus 4. Just check it out. It's a minus 4. So minus 4 means 3 minus 4. Okay. Then plus. Then the value of J is what? 4. 4 minus LC is what? 3. Okay. Now solve this formula. Solve this, and you'll get the address of 3, 6th element. So 1430 plus 4. Now here 6, 3 minus will be plus 7. 6 into 7 will be what? 42. Plus 4 minus 3 will be what? 1. Square bracket is here. Now 1430 plus it is what? 4 into 43. 1430 plus. If you multiply this, 4 3 are 12, 4 4 is 16, 17. Okay. So this will be finally 2, 10, 6, 1. 1602. The address of ijth element will be what? 1602. I hope I have explained thoroughly. And such type of question will have in the examination. This is completely formula based question. So this is the way, and this is the way to solve. Please remember this. And if any doubt, you can ask through the comment section. Okay. This is the one question of row measure I have solved. I'm going to solve the one question of column measure. See, here I am with the next question, that is of column measure implementation. Okay. So the same formula, only instead of n, here we'll write r for the number of, instead in case of column measure, we require the number of rows. Okay. So again, we'll try to find the things, this is LR, this is UR, this is LC, and this is UC. So try to find the values. B, base address. What is the base address? 4110, 4110. Now what is the value of W? Width of each element contains double type. Indirectly it is given. Double type, the size of double data type is 8. So that also you have to remember. So here the W will be 8. Each elements will require 8 bytes. So width of each element is what? 8, double type. Okay. Then value of W, then value of LR. The value of LR, get it from there, -2. The value of LC. The value of LC is what? 3. Okay. Now value of I, the address of which element? We have to find the address of D4, 5. And so I is 4 and J is what? 5. Okay. D4, 5. Then we'll find the number of rows, that is UR minus LR plus 1. Row, R for row here, UR LR minus 1. UR minus LR plus 1. So here, what is UR? UR minus 10 minus -2 plus 1. That is what? 12 plus 13. The value of R will be what? 13. Now put these things in the formula and get the value. So here the address will be what? So put in the formula address of, like this you can write address of. It's a proper way to solve the question. 4, 5th element equal to the value of B is what? 4110 plus W is what? 8 square bracket. I minus LR, I is what? 4 minus LR is what? -2 plus number of rows here 13. J minus, sorry, what is the value of J? J is 5. So 5 minus what? J minus LC. The value of LC is what? The value of LC is 3. 3. Put the things in the formula and get the value. So here you can solve it. 4110 plus 8. Now here 4 minus 2 minus will be plus 6 plus 13 into 2. Okay. Then just a minute. Okay. Now 4110, 13. The 4110 plus 8 into here 13 into 26, 26 plus 6, 32. Now 4110 plus 256. Okay. Now if we'll add 6, 6, 3, 4. 4, 3, 6, 6. This is the address of 5th element. So here I have solved 2 questions, one question of row measure and one question of column measure. Okay. And I've tried to explain thoroughly, very well, as much I can. Still, if you have any doubt, please ask through comment section. Okay. Now, second thing, I will upload another video in which I will discuss, there is different ways to ask this question. So this is the first way I have taught. Simple formula based question. LR, UR, LC, UC will be given. You'll put the things in the formula. There is another way to ask the same question that I'm going to discuss in my next video. Till that, watch this video thoroughly, and if any doubt, make it clear through the comment section. Okay. So thank you for this. Thank you for watching this video. And now Let's see you in next video.